Welcome to our third shot in sustainable engineering. In this presentation, we're going to look at energy reduction and sustainable cooling systems. Areas we're going to look at within this part of the presentation, we're going to look at vernacular design principles, the courtyard effect, solar tubes and wind catchers, the use of water and plantation within our designs, and how shading and solar gains greatly affect our buildings. I gave you an insight into vernacular design principles in our last presentation. Here we'd like to take them a stage further. Now, looking at the way that wind direction and seasonal shading affects our buildings will greatly help us in designing structures. If you look at the top and right hand corner of the screen, you'll see a map showing where the sun rises over the buildings in the summer and where it moves on a path in the winter. As it moves over the buildings in the summer, we have high level sun shining down high heat levels down onto our buildings. We want to reduce this effect on the building by maximising any shading over windows to stop the sunlight moving into the building, because it can create overheating within our structures. Where in the winter we want to capitalise on these sun rays, pushing them in deep into the building to be able to heat up the building in the colder seasons. So orientating our buildings so that they can maximise these sun rays is important. And we also need to know that which side of the equator we're on, so we can understand how the sun's direction onto our buildings, which is the sun orientation to the north of the planet is different to the sun orientation on the south side. Also, the way we lay out our structures within our camps needs to be done to maximise wind directions. If you look in the centre of the screen on the right hand side, you'll see that the buildings have been laid out to take the maximum northerly winds blowing through the site. This allows them to move around the trees, cooling them down through the shaded parts of the building, and then blow into the structures through large low-lying windows, allowing cool air into the structure, but pushing out of the buildings through high-level, smaller windows where the warm air will get pushed. If you can then align this between trees, between the buildings, then what that will do is naturally cool down the air again before it's pushed into the next structure. On the bottom left hand corner of the screen, you can see how this has been done in a modern way. A large amount of water around the outside of the building allows airflows to come in underneath the trees and cool down before they enter the structure. They're then sucked into the building at the lower levels, move through internal trees which are supported by glazing, and they channel the warm air into the centre of the building, which is then released through fans at the top of it. This maximum use of shading and cool air enables us to cool down the buildings without mechanical means. This has been done for thousands of years, and here you can see some basic effects from the Middle East and China where this technique has been used and is still used effectively today. These courtyard effects allow cold air to be sucked in through the centre of the building, through areas where there's normally water effect around and little sunlight, to allow the airflow to be cooled down before they're pushed through the buildings and sucked through low-level windows on the outer face of the building. This keeps the courtyards and the rooms around them cool throughout the year with little mechanical means. Solar tubes and wind catchers are different methods on how we can use them to circularize the airflow through a building without mechanical means. Wind catchers or wind towers are buildings where parts of the building which have been designed to catch cold airflows higher up in the atmosphere and bring them down into the building. In the bottom left hand corner of the screen you can see two examples, one from the Middle East and one from a development in central London. These have been located to catch these higher winds and push that air down into the building, circulating it low in the building as it then filters up. Where solar tubes or solar chimneys are positioned on the opposite side of the building. These are designed to get heat by the solar rays, and they push the airflow high into the structure to be released. The combination of the two techniques allows the building to be cooled without any use of mechanical means. The use of water and plantation within a structure can greatly increase the velocity, which you'll see in the last slide. Using plants to create humidity and add cooling effects within the building can greatly enhance the movement of airflow. As you can see on the far right hand side at the bottom, the wind catchers catch the airflow higher up and has channeled it down to the bottom of the building. It then moves across a vase full of water, which again takes some of the heat out of that airflow, cooling it down. It's then being released through the cellar into the building, which then filters up as it warms into the higher elements of the building and is then released. This is a methodology that's been used in the Middle East for many years, and there's a number of different ways it can be done. It can be done for having courtyards with lots of plantation, where the airflow is brought down into the building through the courtyard. The plantation then cools it down through humidity, and that airflow is then sucked through the building and released further to reduce the temperatures across the structure. Another technique, in line with the ones we've just seen, is using the maximum use of shading and solar gains. As we've already spoke about, as the sun moves across the earth in different seasons, it can affect buildings differently. If you look at the diagram on the right hand side, this is shown in a bit more example. The use of areas such as trees can shade buildings in the summer while allowing the sun's rays through them in the winter as they shed their leaves. Or putting slats shading on the outside of a building will block sun's rays in the summer, but as the sun moves lower in the atmosphere into the winter months, the sun's rays will be able to penetrate through the slats into the building, heating up the internal areas. This is an easy way of maximising or reducing the sun's effect on a building. As you can see in the bottom left hand corner, again this is no new technique and has been in use for thousands of years in different areas. This building in China has had its eaves designed to reduce the impact of the sun's rays in the summer, giving maximum shading across the external verandas. It also has movable walls, which can be moved at different seasons around the building to reduce the sun's rays on the building and provide maximum shading. This utility and movement in a building is a great way to increase the environmental warming and cooling within a structure, and it's not a new technique, as you can see. So this was a very slight insight into the different methodologies what can be used in vernacular design. So a couple of areas we'd like you to look at in discussion is, how could we incorporate these into modern military structures? Can we actually have areas where plantation are put to reduce temperatures? Could we use solar tubes and wind catchers within our accommodation to be able to maximise airflows and reduce the amount of mechanical ventilation we need? Any opportunity would be a good one to reduce our energy demands and operations. Thank you once again for sitting through this presentation, and we hope you enjoyed it, and we look forward to speaking to you again on the next one.